So we're going to look at two other types of transformation today. So yesterday we looked at the vertical stretch, vertical compression, right, and the reflection. Today we're going to look at two other types of transformation. Remember that your parent function is, what's the parent quadratic function? Y equals, what's the parent quadratic function? Y equals what? X squared. So what happens to my graph, to my parent function, if I add something to it? So if I have x squared plus 5, or if I have x squared minus 1, what happened to my graph? So my original graph, which we know that this is my original graph, okay? What happened to that graph if I actually add 5 or subtract 1 or add 7 or I don't know, okay? This is what we're going to look at today. That's the first part, okay? So we call that number that we add outside the x squared, we call that the letter k. So it's x squared plus k. We symbolize it with the letter k, okay? Other textbook might use d. I don't know, okay? But here we use x squared plus k, okay? So basically your k value in this case is 5. Your k value in this case is -1, okay? So we're going to take it to the decimals, and then we're going to graph these 4 or 5 different functions, and then we're going to see what happened to the graph once I add 2 or I add 4, I subtract 1 or I subtract 3. Okay? Now before we start, can we identify the values of k? So what's the value of k here in y equals x squared plus 2? 2. What's the value of k in C, x squared plus 4? What's the value of k in D? -1. And what's the value of k in E? -3. Okay? So do we identify the value of k here? Let's see, let's take it to decimals and let's graph to see what happened, to investigate what happened when I add these things. So we always start with our original function, which is y equals x squared. So that's my original parent function. Now what would be my second function? Y equals, what's the function in B? X squared plus what? 2. Okay, let's zoom in a little bit. So the red one is x squared. The blue one is x squared plus 2. What do you notice? It was moved up. How many units was it moved up? 2 units. Okay. Now let's look at, is it still opening upward? Yes. Now let's look at the vertex. What's the vertex now? What's the vertex? Vertex is a point. What's the vertex? 0, 2. Right? The vertex is 0, 2. What was the vertex before? 0, 0. So what changed when I added that 2? What changed from my vertex? Which value? The x value or the y value? The y value changed. Do we remember yesterday what did we say about the y values? What does it represent? Axis of symmetry or optimal value? Optimal value. Okay, so it looks like the optimal value has changed here. Let's look at the third one. So what was the third one? Y equals x squared and then plus 1, plus 4. Again, what do we notice here? It moved up. We always compare to the original one, so we always compare to the red one. So to the red one, it moved up 4, right? So that plus 4 caused my vertex to move up, or caused my whole graph to move up 4 units. Okay? Now let's look at something here. Did my step pattern change? So if I look at my step pattern here, I go up 1. Can I use a different color? Okay. I go up 1 over 1. Then I go up 1, 2, 3 over 1. Did my step pattern change from 1, 3, 5? No, it did not. Right? My step pattern did not change. The only thing that changed is the vertex. And what part of the vertex that changed? Vertex changed. What's my vertex here? 0, 4. So you see that value of the y value of the vertex matches the k value. Do we see that? Okay. So what do we call this? So if I'm moving my graph vertical 2 units next function squared minus 1. Okay, so I'm going to hide this. So what do we notice here? It moved down 1 unit. Did it flip? No. Should it flip? No. What makes my graph flips? When the a value is negative. My a value here did not change. My a value, if you look here, a value is 1, a value is 1, a value is 1, a value is 1. So my a value did not change. Therefore, my step pattern will not change, nor my direction of opening. Is that clear for everyone? Okay? So what happened here is from this graph to this graph, I have what we call a vertical translation. Again, same thing, vertical translation, but I'm going to say vertical translation 1 unit down. Okay? So I moved my graph and I took it and I moved it down 1. Okay? What's my vertex here? 0 and negative 1. Again, we're seeing that the vertex here is 0, 0 because my k is 0. I don't have a k. My vertex here is 0, 2 because my k is 2. My vertex here is 0, 4 because my k is 4. My vertex here is 0, negative 1 because my k is negative 1. Does that make sense? Okay, then my next graph was what? Y equals what? I'm going to zoom out for a second. Okay, look here. This is where my vertex. Again, I have a vertical translation. What's the vertex here? 0 and what? Thank you. Do we see that? Is that clear? Okay, so let's go back to our... So, direction of opening for all of them. second one. Exactly. If I'm going to draw an axis of symmetry here, it's going to be this, right? An axis of symmetry for the blue one, it's going to be on the same line. On the axis of symmetry for the red one, it's going to be on the same line. For all of them, the axis of symmetry is the same. Because remember yesterday we said that the axis of symmetry is the x value of your vertex. And if you look here, all the x value of the vertex is 0. So in this case, the axis of symmetry did not change. So the axis of symmetry is x equals 0, x equals 0, x equals 0, x equals 0. They're not going to change. So the axis of symmetry here matches the x value of the vertex. Okay? And the y value of the vertex matches the k value of my function. So we said that my graph was vertically translated. So I'm going to just write this vertical translation. Okay, I won't be writing it every single time. So what I will write instead, I will write VT. You guys can write VT on the test. I will understand what you're saying. Okay, so vertical translation. So anytime you see VT, I'm talking about vertical translation. So I have vertical translation 2 units up. So when I'm asking you for your transformation, I'm looking for these sentences. Okay? I want the full sentence. I don't want shortcuts except the VT. You can write VT. But I don't want VT2. It doesn't make any sense. I want VT, vertical translation, 2 units up. This is going to be vertical translation 4 units up. How about the next one? Vertical translation. How many units? 1 unit which way? Down. Okay? So instead of saying -1, I say 1 unit down because the negative represents down. And then the last one is going to be vertical translation 3 units down. Okay, remember we call this number that's outside the x squared, we call it the letter k. Okay? We're going to refer back to this later. And then you're going to see A, the K, and the H. We're going to talk about this later. Okay? So, if K is positive and greater than 0, then the parabola shifts which way? So if K is positive, then the parabola shifts up. If K is less than 0, so K is negative, right? Then the parabola shifts down. So the value of k describes the vertical translation of the parabola, which is known as the optimal value or the y value of the vertex. Okay, so remember that if you have the vertex, you have the x and the y. The k represents the y. Okay. So if I'm looking at this graph, it's asking you for each of the following, state the transformations and graph the parabola. Okay? So here are the steps that you have to follow. So I'm looking at this, y equals x squared plus 3. So if I'm looking at the transformation, where would my transformations be? So remember that my original is y equals x squared. What did I do to change it? Added 3. So what does that 3 represent? The value of k. What does k does to my graph? Move it up. So what do we call this? How do I write this? Vertical translation. Okay. 3 units up. In order for me to be able to graph, I'm going to have to use my vertex. So where's my vertex? What would my vertex be? 0, 0, 3. Remember that because it used to be at 0, 0, right? But then I moved it 3 units up. So now it's not at 0, 0 anymore, right? I moved it 3 units up. Does that make sense to you? Okay, so my vertex is where now? 0, 3. Okay. How about my step pattern? What's my step pattern? Because it's 1, 3, 5. Okay, so let's see how we're going to graph this. Okay, so this is my x, this is my y, and 1, 2, 3, -1, -2, -3. So let's locate the vertex. So where would I locate my vertex? 0, 3. So 0, 3. So this is my vertex. Yes? I found it. It's right here. Then from the vertex, how much do I go up? Go up 1 over 1. So go up 1 over 1. I can do the same thing to the other side. And then from this point, how much do I go up? 3. 1, 2, 3 over 1. So that's going to land me right here. Right? If I go 3 from this point, 1, 2, 3 over 1. So I'm going to land right here. And if I have room to fit 5, so that would be go up 5. So 1, 2, 3, 4, 5 over 1. But I don't have room. So I'm going to be satisfied with this. I'm going to join my points like so. Yes. Because you're adding 3, right? So you have a vertical translation 3 units up, right? Which makes your vertex at 0, 3. Right? So if my vertex is at 0, 3, 0 is right here, and then 3 is right here. So that means this is where my point. Okay? So locating your vertex is very important because that's your starting point. Okay? I'm going to give you some time to try the second one.